Now there's two parts to Descartes' rule. We're going to look at number 34 really quick. It says f of x equals x to the third plus 7x squared plus x plus 7. Now when you use Descartes' rule, what you have to do is you have to look at the signs and see if they change. So right here it says positive x to the third and then positive 7x squared. So was there a sign change from there to there? No, there's not. And if I go from there to there, those are both positive also. So again, we don't have a sign change. Again, we don't have a sign change. When we don't have any sign changes, when you haven't done anything to the function, that means there's going to be 0 positive. Actually, I should say possible positive. 0 possible positive zeros.
Is it rational?
Rational.
What's the difference between rational?
Okay. You'll get your test back. Chill. Okay. The other part to Descartes' rule is finding the possible negative zeros. And to find the possible negative zeros, we have to plug in negative x and see if the sign changes at all when we do that. Now I'm going to do most of this mentally. So we have negative x to the third, and then we have plus 7x squared. Because of the square, the negative doesn't matter. And we have minus x plus 7. Do we have a sign change right here? Yes. Okay, so there's one yes. Do we have a sign change right there? Okay, we have another sign change. And finally, last one. Yes. Okay, this one. Now, they don't always go all no or all yes. This is just the example that we're looking at. So because there's 3 yeses, that means there's 3 possible negative rational zeros. Did I do something wrong here? Oh, yeah, I'm not done yet. So 3 is the most, and then depending on how many you actually have, it goes down by 2 each time. So you either have 3 total, or you have 3 or 1, and it always goes by 2. So possible rational zeros. Now if you ended up with 5, then it would be 5 or 3 or 1. If you ended up with 4, then it would be 4 or 2 or 0. Okay, so it keeps going down by 2 possibilities. Now, this actually does come in handy. When you're finding all possible rational zeros and you're trying to pick which ones you should try, just test, this might come in handy. Like if you knew that there are no possible positive zeros, then you wouldn't try any of the positive numbers. You would only try the negative numbers. So it kind of helps, limit what you need to test. Okay, let me show you a yes/no one. Number 35. It says f of x equals 5x to the third minus 3x squared plus 3x minus 1. Oh, that's not a yes/no one. But this is a yes, yes, and that's also a yes. So this is for positive numbers. So there's going to be 3 or 1 positive rational zeros. But if I plug in a negative, maybe we'll get what we're trying to get at here. So if I plug in a negative, I'm going to get negative 5x to the third. It's going to be negative 3x squared, negative 3x minus 1. And so this is if I plug in a negative x. Right here it's a no. Right here it's a... Dang it, are they all no's?
Yeah.
Dang it. Let's find an example where they're not all no's. So this one has no possible rational zeros. Yeah, that's right. Let's just make up one. Okay, so let's say f of x equals x to the fourth plus 3x squared minus x plus 1. No, if there's 3 no's, that means there's no, because you have to have a yes to have a possible rational zero. So this is 1, 2, 3 possible positive ones. So look at this one. This one's a no, right? because they're both positive. That's a yes, and that's a yes. So because there's two yeses, that means you can have two possible positives.
And one negative.
Hold on, we're only doing positives, or 0 possible positives. Okay, now to find out the negatives, you have to take the same function and plug in a negative x. So when I plug in a negative x for this one, I'm going to get x to the 4th minus 3, no, plus 3x squared plus x.
It's a minus 2x squared.
Yeah, it was minus, but when I plug in a negative x, it becomes plus. So this one, because there's no sign changes, there's going to be no negative possible rational zeros. Does that make sense?